right, today we're going to do 4.2. We're going to learn about linear patterns. Your learning target, you can identify if a relationship is linear or non-linear from a table. So this lesson is going to encompass a couple days. So this is really 4.2a that we're doing. So make sure that you write 4.2a so you know when we organize our notes that this one is going to go first. Some vocab words aligned with this lesson. You need to know the word linear. Linear moves at what we call a constant rate. And when it moves at a constant rate, we are talking about a straight line. For example, if I had a coordinate plane, a linear relationship would move at a nice straight line. I can move around anywhere. That's a decreasing straight line. I have a vertical straight line. It's still linear. A horizontal straight line. As long as it's a straight line, it's a linear relationship. Nonlinear, then, doesn't move at a constant rate. And it is not a straight line. Some examples of nonlinear equations given a coordinate plane. An example of a nonlinear, anything with curves. This is called a parabola. It is nonlinear. It's curving. Another example would be like this. Again, it's a nonlinear. It's not a straight line. Another example, they can trick you up a little bit. They can make it look, hey, look, I'm linear, and then bam, I'm going this way. Although you have two line segments, it is still not a constant rate. Constant rate means it keeps going at that particular level of change. How you're going to apply linear and nonlinear vocab, you're going to determine if you have a linear relationship from tables. You need to know how. With linear, x and y are added or subtracted, so you are added or subtracted by the same thing constantly. The key word is constant. You have to check every value and you have to see if they're changing by the same thing always. If not, they're nonlinear. Let's do an example of a linear relationship. Your tables are going to look like this today. You're going to have an x and a y. X, let me do 0, 1, 2, 3. Y, let me do 4, 6, 8, 10. And when we say they're changing, they are being added and subtracted by the same thing constantly, what that means is I look at my x's. I look at two different parts. My x here, I'm added 1. I added 1. Same thing. I added 1. My y's, it looks like I added 2. From 6 to 8, I added 2. From 8 to 10, I added 2. This is a linear relationship because the x and y's are being added by the same thing constantly. It didn't change. Nonlinear, we're going to get into this first example tomorrow probably when I come back. X and y are multiplied or divided by the same thing, or they don't have a pattern. And with our homework today, it's more going to be isolated on the second point. So what we want to know, linear, again, creating a T-chart, we have linear and we have nonlinear. Linear examples, you're adding or subtracting by the same thing to both sides. And you got to look at it in two separate ways. Notice here we looked at the x's, how did they change? And then I looked at the y's, how did the y's change? Since the x's were being added by 1 constant, and the y's were being added by 2 constant, it's a linear equation. And nonlinear out for today is just going to be no pattern. I think I do have one problem in your homework where you're multiplying or dividing x and y to get the other value. If you're multiplying or dividing, you're growing faster. It's kind of like an exponential growth. You're going super fast. So you don't want, that would be a nonlinear situation. I'm going to show you how to work through some examples. This is exactly how your homework's going to look. You're going to be given some tables, and from the tables you're going to say, is this linear or nonlinear, and why? So again, I break it up into two sections. I have an x section, and I have a y section. And I want to see how are my x changing, and how are my y's changing. Looks like to get from 2 to 5, I added 3. To get from 5 to 8, I added 3. From 8 to 11, I added 3. All right, so x is a constant. Now I just got to confirm that y is constant. -4 to 2, it looks like I added 6. From 2 to 8, again I added 6. And from 8 to 14, I added 6. So since my x's are a constant change and my y's are a constant change, this would be linear because x and y are changing constantly. I guess in the next example, I'll show you a shorter way to do it because I feel like this takes a long time. The key word is constant. Constant means line. All right, next one. Again, breaking it into two. I have the x section, and I have the y section. All right, I'm going to check my x's out. From 0 to 2, I added 2. From 2 to 3, I added 1. From 3 to 7, I added 4. Now think to yourself, is this a constant change? I would say no, I can be done already. I would say nonlinear because you change what you're adding every time, or because it is not a constant thing you're adding. Okay, so nonlinear because it's not a constant change. Next one. Again, we have two sections here. We have our x section and we have our y section. And we're looking at both of them separate. X, from 3 to 4, I added 1. Y, from 4 to 5, added 1. X, from 5 to 6, added 1. You can't really see that, plus 1. So this looks constant, that's good. Here, I added 3. From 10 to 13, I added 3. From 13 to 16, I added 3. Think to yourself, does this mean I'm linear or nonlinear? I'm adding by the same thing every time on the x side. I'm adding by the same thing every time on the y side. Since they're always constant, I'm going to say it's a linear relationship. And I'll say always adding by the same number. And notice that I'm putting adding in capitalized letters because eventually we're going to talk about multiplying. And if you're multiplying again, like I said on the first slide, that's a nonlinear situation. So we're always adding by the same value. All right, the next one. -3 to -2, looks like I added 1. -2 to -1, I added 1. -1 to 0, I added 1. 12 to 9, looks like I subtracted 3. That's okay, because subtracting is like adding a negative, so it's okay. 9 to 6, I subtracted 3. 6 to 3, I subtracted 3. So again, I'm looking at, I have a constant thing I'm adding on the x. I have a constant thing I'm adding to the y. This would be a linear, because adding by the same value constantly. And that's pretty much our I-cans for today. And let's just recall what our I-can statement was from the beginning. It said that you can identify if a relationship is linear or nonlinear from a table. You did it. We did it the last page. We were given a table, we analyzed the change, and we determined if it was linear or nonlinear. And that's our lesson for today.